Let's get started on today's notes over an introduction to conic sections, and we're actually going to focus on circles today. So first I want to talk about what are conic sections. Conic sections are formed by the intersection of a double right cone and a plane. So as you can see, I have four examples here, and a double right cone is like a cone at its base and then a cone on top of it flipped upside down. That's a double right cone. And as you can see, I have a plane that intersects each one of these at a different angle. In the first one that I want to point out, you see that the plane is parallel to the base. When the plane is parallel to the base, and that's just the symbol for parallel, when the plane is parallel to the base, it forms a circle. Okay, if I were to look on top of the cone, like at a different angle, I'm looking on top of the cone, I can see that the intersection of that plane and that cone forms a circle. Let's move on to the next one. If I tilt that plane so that now it's at an angle, it's not parallel to the base, let's write that down. The plane is not parallel to the base. It forms a different shape right here. It forms what's called an ellipse. It's like a circle that's been stretched out. And now if I tilt that plane even more so that that plane is parallel to the side of this cone, and let's write that down, the plane is at the same slant as the side of the cone, so that you can see that the plane, it goes out like the end of the cone, either the bottom or the top, whatever. It's going to form what's called a parabola, which you're probably used to hearing at this point. Whenever you're learning conic sections, you've probably been exposed to parabolas at some point. So I'm just keep tilting that plane, right? I just keep tilting it. It was parallel to the base, then I tilted it a little more, created an ellipse, and a little more, created a parabola, and if I tilt it even more so that the plane is perpendicular to the base, it's going to form what's called a hyperbola, where I have two parabolas, if you will, basically on opposite ends of each other. Okay, so they go out in opposite directions. And those are the four conic sections that we're going to talk about over the next several videos. And today we're going to focus on the circle, which you've been exposed to at this point. The definition of a circle is the set of all points that are the same distance from a fixed point. That fixed point is the center. We'll call that HK. The distance from the center to any point on the circle is the radius, and it's all the same. So now let's talk about graphing circles. When we're graphing circles, we're going to deal with this equation that I have on your PDF, on your notes, or on the screen right here. It's x minus h. Remember that the center point is HK. The center of this circle is HK. So your equation is x minus h squared plus y minus k squared equals your radius squared. So your radius, remember, right here is the distance from the center to any point on the circle. So let's move on to graphing circles. We're going to work through these two problems right here where we're going to graph these circles on the coordinate plane. And the first thing we're going to do is identify the center and the radius. So given this equation right here, x minus 4 squared plus y minus 3 squared equals 4, the center is going to be 4, 3. It's the opposite of what you see inside the parentheses, because the equation affects at x minus h squared plus y minus k squared. So that's typically what you'll be thinking whenever you're graphing. It's the opposite. So x minus 4, my x value for the center is positive 4, and then y minus 3, the y value for the center is 3, and that's kind of a funky looking 3. Sometimes it just does that. So now let's graph that center. I'm going to go right 4 and up 1, 2, 3. There's the center of my circle. And now let's talk about the radius. Remember, this right here is r squared according to my equation. So I'm actually going to take the square root of 4 to get what the actual radius is. and the radius here is 2. So I'm going to go out 2 in every direction, up, down, left, and right from that center point. And there's my circle. I'm just going to connect those points, and there's the center. Let's move on to example number 2. In example number 2, the center point is, this is x plus 1 squared, and remember you're going to take the opposite of what that is. So essentially, this was x minus h would have been negative 1, right? H would have been negative 1 to end up with a plus 1 in there. So in this case, h is negative 1 and k is 0. I don't have any translation. I haven't moved this circle up or down at all. So the center point is at negative 1, 0, and that's on my x-axis. So now let's identify the radius. Remember, this is r squared. Your radius is not 25. Your radius is the square root of 25, which is 5. So from my center point, I'm going to go out 5 in every direction. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 and up 1, 2, 3, 4, 5. And then I'm going to connect those points. And that's the best circle I can draw. So that's how we're going to graph circles. Let's move on to writing equations of circles. So what do I need to write an equation of a circle? I need my center point, HK, and I need the length of the radius. I need the radius. So this says find the center and radius of a circle. Okay, so I'm not writing an equation here. I'm just finding the center and the radius of a circle that has a diameter with endpoints -4, -2, and -1, -6. Okay, so I need to find the center and I need to find the radius. Okay. All right, so I know that the radius is going to be the diameter divided by 2, right? It's going to be half of the diameter. So let's do that first. And you can go in any order, but I'm going to do the radius first. So the radius, I'm going to use the distance formula for this. The distance between these 2 points is, I'm going to take the square root, and recall that if you don't remember that the distance formula between, like finding the distance between 2 points, we did that in yesterday's lesson or in the previous lesson. So you can go back and go into a review of distance, midpoint, and completing the square. So the distance formula, that's just my little formula where I subtract my x's, square them, I subtract my y's, square them, I take the sum of that, and then I take the square root of all that. So the distance between these 2 points, I'll label this x1, y1, x2, y2. I'm going to subtract my x's, so that's -1 minus -4 squared. Remember, that's just plus a positive. And I'm going to add that to the difference between the y's, which is -6 minus -2. That's just plus 2 squared. And now we're going to do a little bit of this at a time. So the first thing is -1 plus 4 is +3. +3 squared is 9. Plus -6 plus 2 is -4. -4 squared is +16. This means the distance between the 2 points is the square root of 9 plus 16, which is 25. What is the square root of 25? It's 5. So the distance between those 2 points is 5. That's the diameter, which means the radius is 5/2, or 2.5 for those of you that are decimal people. 2.5. Let's move on to finding the center. The center of this, let's write here. Center is going to be at the midpoint. So we're going to use that midpoint formula that we did in the previous lesson as well, where I add my 2x values and divide it by 2. I add my 2y values and then I divide that by 2. So let's do that. I'm going to add my 2x values, -4 plus -1, and I'm going to divide by 2. I'm going to add my 2y values, -2 plus -6, and then I'm going to divide by 2. Negative 4 plus negative 1 is negative 5. Negative 5 over 2 is negative 5 over 2, or negative 2.5. Negative 2 plus negative 6 is negative 8. Negative 8 divided by 2 is negative 4. So the center point for this circle is negative, and you can write 2.5, that's fine, comma, negative 4. So that's all we needed to do for this example number 3, was find the center and the radius. And I just used the distance formula to find the radius, and I used the midpoint formula to find the center of the circle. That's all we needed to do for that one. Let's move on to the next 2 examples where we're actually going to be writing equations of circles given some information. So this example number 4 says to write the equation of a circle with a center at negative 12, 8, and a radius of 5. So here I have HK. H is negative 12, K is 8, and the radius is 5. So given our formula, x minus h squared plus y minus k squared equals r squared, I'm going to plug in these values. So x minus h would be x minus negative 12, which is x plus 12, squared, plus y minus 8 squared equals the radius squared. If the radius is 5, 5 squared is 25. And that's how we write that equation. Let's move on to the next one. Write the equation of a circle with a center at 5, 7, and it passes through the point 8, negative 6. Okay, I know that HK is 5, 7. But I don't know the radius. Okay, I do not know the radius. I just know that I have the center point here and a point on the circle. But I do know that the distance from the center point to the point on the circle is going to be my radius. So let's find that. Okay, I know that the distance between those 2 points, which is the square root of, and I'm going to subtract the x values. So 8 minus 5, and then I'm going to square those, plus negative 6 minus 7, and then I'm going to square those, which means I get, let's see, the square root of 8 minus 5, that's 3. 3 squared plus negative 6 minus 7 is negative 13 squared. And now I've got the distance being the square root of 9 plus negative 13 squared is 169. And let's see, the square root of 9 plus 169 is 178. Now, here's something that we need to think about. I know that the formula for the equation of a circle, or the equation of a circle, is written like this: x minus h squared plus y minus k squared equals r squared. So the distance of the, let me just redo this right here. This right here, instead of d, I'm going to write r, right? Because that's really what we're finding, right? The distance between these 2 points is my radius. So the radius is the square root of 178, which means the radius squared is just 178, right? I don't need that square root, right? If I square both sides, like radius squared, that undoes the square root. Okay, so the radius squared is 178. I don't need to worry about like simplifying this non-perfect square root and all that kind of stuff. So now let's plug in our values. X minus h squared, remember we have hk is at 5, 7. So that's going to look like this: x minus 5 squared plus y minus k, that's going to look like this: y minus 7 squared equals, and then my radius squared, we wrote over here, is equal to 178. So let's move on to our last couple of examples where we're going to be writing equations of tangents. So circles and tangents. And you may recall this from geometry, but if you didn't, I will go over it. So circles and tangents. Let me just refresh your memory. A tangent is a line that intersects a circle at exactly 1 point. it's perpendicular to the radius at the point of tangency. So given this circle right here, this blue line is a tangent and intersects the circle right here, and it is perpendicular to the radius. Okay, so here's your steps to write equations of tangents. I'll let you refer to these steps as you're working through this, but let's just kind of do each one at a time. Okay, so the first thing that we're going to do whenever we're writing equations of tangents is we're going to identify the center and the radius of the circle. And we're going to find the slope of the radius at the point of tangency. The slope of the radius at the point of tangency. That's like saying this red line up here, I'm going to find the slope of it. Okay? The slope of it. Right? Change in y over change in x. And then we're going to use that slope to find the slope of the tangent. So I'll actually go back and I'll say, okay, step 1, step 2, step 3. So number 6 says, write the equation of the line that is tangent to the circle x squared plus y squared equals 100 at the point 8, 6. Okay, so in this particular problem, the first thing I'm going to do is identify the center and radius of the circle. That's step 1. The center would be 0, 0. And the radius is what? If the r squared is 100, then the radius is 10. Let's move on to step 2. Step 2 says to find the slope of the radius at the point of tangency. Okay, so what I'm going to do in step 2 is I know that my center is 0, 0, and the point of tangency is 8, 6. So what I'm going to do is I'm going to find the slope of the center, which is 0, 0, and the point of tangency, which is 8, 6, using my slope formula, right, which is y2 minus y1 over x2 minus x1, right? That's change in y over change in x. So let's just write that down. So I'm going to subtract my y values, which is 6 minus 0, over subtract my x values, which is 8 minus 0, and I get 6 over 8, which is 3 over 4 simplified. So we've found the slope of the radius at the point of tangency. Step 3 says to use the slope to find the slope of the tangent. If the tangent is perpendicular to the radius at the point of tangency, then the slope of the tangent line is going to be the opposite reciprocal. Okay, so we got to go back to what we know about perpendicular lines. If the slope of the radius is 3 over 4, the slope of the tangent line is negative, flip it, 4 over 3. So here you're going to take the opposite reciprocal. Okay. All right, now step 4, the very last step, says to use the slope from step 3 and the point of tangency to write the equation of the tangent line in point slope form. Okay, so in point slope form, I am assuming that you remember point slope form, but I'm going to use this point right here, 8, 6, and I'm going to y minus 6 equals my slope, which is negative 4 over 3 times x minus 8. That's point slope form. And I can simplify this. Some teachers, I wouldn't really care. You could just leave it like this. But I'm going to go ahead and simplify it. So, or put it in slope-intercept form, I guess. Y minus 6 equals, distribute that negative 4/3, negative 4/3 x. Negative 4/3 times negative 8 is going to be positive 32 over 3. 32 over 3. And then I'm going to add 6 to both sides. So y equals negative 4/3 x plus 6. Well, that's going to be 32 over 3 plus 6 over 1 is 32 over 3. I need a common denominator, so I'm going to multiply that by 3, and I get 18. And I get 50 over 3. So plus 50 over 3. And that is the equation of the tangent. Again, each of these equations works. That's in point-slope form. That's in slope-intercept form. You just need to figure out if do you want to simplify it or not. I typically do not care if you simplify it. So let's move on to example number 7. This is the last example in these very long notes, which I apologize. There's just a lot to get through. It says to write the equation of the circle that is tangent, hold on, write the equation of the circle that is tangent, x equals -4, x equals 6, and the x-axis if the center of the circle is in the 4th quadrant. Okay, so that should say write the equation of the circle that is tangent to x equals -4, x equals 6, and the x-axis. So this should say 2. Okay. So what are we saying here? We're writing the equation circle that is tangent to these lines. Let's draw a little graph, okay? And I'm going to draw them in different colors so we can kind of get an idea of what we're looking for. The line x equals -4 is a vertical line. So here's x equals -4, and x equals 6, which is 1, 2, 3, 4, 5, 6. Okay, here's x equals 6. Now, these vertical lines are 10 units apart. I just want to note that, right? These are 10 units apart. I'm going to write that down. 10 units apart. And it's tangent to those lines. It's also tangent to the x-axis. That's right here at y equals 0. And the center of the circle is in the 4th quadrant. Okay, the center of the circle is in the 4th quadrant. So let's think about this. I'm going to use blue right here. If these two vertical lines are 10 units apart, that would be the diameter of the circle, yes? Because if it's tangent, it's only going to intersect those lines at one point, right? If it's 10 units apart, that's the diameter. That means the radius is 5. So the diameter is 10, which means the radius is 5. So we're going to be 5 points from this line, and this line. Where would that be? Well, my center point, right, 5 units from x equals -6 is going to be when x is 1, which is right here. And it's going to be 5 units down because it's also tangent to that x-axis. So 1, 2, 3, 4, 5. That's right here. Okay? That point right there is 1, -5. Which means this is a point on the circle. This is a point on the circle. This is a point on the circle. What's the equation of this line? I have the center, which is 1, -5. I have the radius. How do I write that? That's x minus 1 squared, right? Plus y plus 5 squared, right? Y minus -5 is the same thing as y plus 5 equals, if the radius is 5, then the radius squared is 25. And that concludes your notes over an introduction to conic sections, as well as an introduction to circles. I hope it was helpful.